Hey everybody, this is Mr. Beckstrom, and today I want to do an example similar to number 13 in the homework here. This is basically using some antiderivatives with the velocity, acceleration, and position functions. So it says at t equals 0, train approaching a station begins to decelerate from a speed of 140 miles per hour according to the acceleration function. A of t is equal to negative 1120, 1120 times 1 plus 4t raised to the negative third miles per hour squared, where t is greater than or equal to 0. How far does the train travel between t equals 0 and t equals 0.2 and between t equals 0.2 and t equals 0.4? All right, so this is going to take a little bit of work here. So let's kind of, first of all, kind of define what we're trying to do. So if we remember, you have your position function, a of t, and then if you take the derivative of that, right, you're going to have your velocity function. And if you take the derivative of that, so f prime of this, kind of take the derivative of that, you're going to get your acceleration function. So we've done this a few times when we were doing derivatives for chapter 2. So the same is true for antiderivatives. If we start with the acceleration function here, we're going to end up needing to take two antiderivatives in order to get to this position function because we're looking for the distance traveled. The first antiderivative is going to give us the speed, and the second antiderivative will end up giving us that position function. And it shouldn't be a of t, it should be s of t. So that was an error on my part. Position function is usually s of t. So s of t, b of t, and a of t. All right. So let's go ahead and first, we know that the volume, or not the volume, the velocity with respect to time is going to be the integral or antiderivative of the acceleration function of negative 1120 times 1 plus 4t to the negative 3 and dt, kind of with respect to t here. All right, so I'm going to go ahead and use a u substitution here. So I'm going to let u equal 1 plus 4t, and the reason being is because then I can replace this whole inside with u, and I know the derivative of u, 1 plus 4t, which I'm going to do right now, the derivative of u is just equal to 4 dt, and I'm going to divide both sides by 4, so 1/4 du is going to equal dt. That way I can do a nice replacement in there for that dt. So when I do this, it should clean up nicely for me. So our velocity with respect to time is going to equal now 1/4 times negative 1120. That's going to be negative 280. Let me just double check here. Oh, that was way too big. Okay. So let's see, 1120 divided by 4. Yep, so that's 280. So I'm going to pull that 280 out front because what I'm doing is for the dt, I'm going to put in this 1/4 du, and then for the 1 plus 4t, I'm going to replace that with u. So negative 1120 times that 1/4, that's going to give me the negative 280, and I'm going to pull that outside of the integrand. And then inside the integrand, all I'm going to end up having left is just u to the negative 3 du. All right, so let's take the antiderivative, or the integral of that, and we're going to get this is going to be equal to negative 280 times, we add 1, so u to the negative 2, and we're going to divide that by a negative 2, so this is going to be equal to 140, positive 140 times, I'm going to replace that u back in there, that was 1 plus 4t, So 1 plus 4t, and that's going to end up being to the negative 2 there. All right, so now I've got my velocity function. And what I know is that my velocity at t equals 0 is equal to 140. So I'm going to go ahead and replace t with 0 and v of t with 140 and go ahead and solve for c, which I didn't forget to put right there, right? Because we need to know what that constant is. All right, so this is going to be 140 times 1 plus 4, replace that t with a 0. This is raised to the negative 2. And plus c is equal to, and this is going to be equal to 140. 140. And if we can see here, that's going to be 0, 1. 1 over 1 squared is just 1, so that's going to be 140 on this side, 140 on that side. We subtract the two 140s, and we're going to end up getting c is equal to 0. So our constant here is equal to 0. So that means that our velocity function with respect to t is going to be equal to just 1 plus 4t raised to the negative 2. Is that right? Oh, times the 140. Go back here, times the 140. I should have put that out front, but that's all right. I'll leave it down front back. Times 140. All right. So now I have my velocity function here, and now I still need to end up getting my my position functions. I still need to go and do another antiderivative here. So I'm going to let u equal 1 plus 4t again, and that's going to make du equal to 4 times dt, and then 1/4 du is equal to dt. So now I'm going to set this equation up in an integral like this. So this is my position function is equal to the integral of 140 times 1 plus 4t raised to the negative 2 dt. And then I can replace dt with 1/4 du and 1 plus 4t with my u. So the 1/4 times the 140 is going to end up being, let me make sure here, should that have been, that's a positive 140 here. Yep, so this should end up being 35. So this is going to be equal to, I'm going to pull the 35 out front because that's 1/4 of 140, and I'm just left with u to the negative 2 du once I do my substitutions. So once again, for dt, I'm replacing that with 1/4 du, and for 1 plus 4t, I'm replacing that with u. And then once I do that replacement and I multiply the 1/4 times the 140, that gives me the 35, which I'm going to bring out front. Now I'm going to go ahead and take the antiderivative. So this is going to equal 35, right? And u is, and let me kind of make sure I separate this nice. So u, so that's going to be plus 1 divided by, so negative 2 plus 1 is negative 1, and then divide by negative 1. So this is going to be u to the negative 1 all over negative 1, negative 1. And this is going to end up, so my position function is going to end up equaling what, negative 35, and replacing that 1 plus 4t raised to the negative 1 power plus c. So let me give myself a bit more room here. So plus C. All right, so now I finally got my position function. So now what I need to do is I'm looking for the distance here. I'm looking for the distance. So the distance is going to be from 0 to 0.2. That's the first one that they asked us to find. And of this, remember, I don't need to, when I'm doing a definite integral, I don't need the C in here because basically the C's are going to end up canceling out, because if we're doing the function evaluated at the upper limit minus the function evaluated at the lower limit, you're going to end up getting a C minus C, whatever that constant is, minuses out. So we don't need to put that in when we actually find a definite integral here. So for the distance, we're going to use the absolute value. So that's the absolute value of negative, oops, hold on just a moment here. I think this is, oh, plus C. So yeah, this is that, I'm sorry. So this is already the antiderivative. So we want to evaluate that from 0.2 to 0. 0.2 to 0. So I was kind of getting ahead of myself a little bit. So really, this is just, remember, when we're talking about distance, so absolute value, negative 35, 1 plus 4t raised to the negative 1. And that is going to be going from 0 to 0.2. And then we're also going to do from 0.2 to 0.4. So when finding the distance, we put it in the absolute value. And that's really doing this one up here, evaluating it from 0 to 0.2. All right, so at this point, I'm going to use my calculator here. So I am going to go to y equals, let's clear this out, and let's put this function in up here. So absolute value, I can go to math, numbers, absolute value, and this is going to be negative 35, and okay, negative 35, and that's going to be 1 plus 4, we can just choose x, that's fine, and that's going to be raised to the negative 1. All right, so I got that in my function here, and I could work this out by hand, but since I have decimals, I'm going to let my calculator do this. So remember, this is just going to be, go to vars, pull up on my y1 function, evaluate it at the upper limit, minus vars, y variables, y1, evaluate it at the lower limit of 0. All right, and so it's going to be negative 15.556 if we go to 3 decimal places. But since this is a distance, we just end up taking the absolute value of that. So the answer should be 15.556 for this one right here. And let's go ahead and do 0.4 to 0.2, and I'll let you do that one. So same thing, just put in 0.4 minus 0.2 and then take the absolute value, then you should get that one as well. All right, guys, if you have any other questions, let me know, and good luck on the final exam. All right, thanks.